Welcome back. We know that AI learns by trying to improve. But how does it know if it's getting better or worse? It needs a way to measure its own mistakes. That's the job of a loss function. A loss function is simply a way of evaluating how well our AI model is doing. It works by taking two things, the model's prediction and the actual correct answer. It compares them and outputs a single number, the loss or error. The bigger the number, the worse the model's prediction was. The entire goal of the training process is to minimize this loss. We want to find the perfect set of internal settings, the weights and biases, that makes the total loss, averaged over all our data, as small as it can possibly be. A smaller loss means our model's predictions are getting closer and closer to the real-world truth. The type of loss function we use depends on the problem we're solving. For regression problems, where we're predicting a number like a house price, a common choice is mean squared error, or MSE. It's a simple three-step process. Find the difference between the prediction and the truth, square that difference to punish big errors, and then take the average of those squared errors over the whole dataset. For classification problems, where we're predicting a category like cat or dog, the most common choice is cross-entropy loss. This is a bit more complex, but its core idea is to measure the distance between the model's predicted probabilities and the true answer. Its most important feature is that it heavily penalizes the model for being both confident and wrong. Now, this connects directly back to what we learned in calculus. It is the loss function that actually creates the loss landscape, that giant, hilly terrain where low points represent good models. For every possible configuration of the model's weights, the loss function gives us the altitude, or the size of the error. So, the loss function is the ultimate guide for learning. It defines the goal. It provides the critical feedback signal that tells our optimization algorithm, like gradient descent, which direction is downhill. Without a loss function, the model would be learning in the dark. In our next lesson, we will revisit that optimization process with a visual explanation of gradient descent.